Hello, today we're going to explain how Excel provides a way of quickly doing repetitive calculations for data analysis or modeling, and how it also provides quick ways of producing equations. First, you can begin by reading each problem. By reading these problems, you can understand what type of projectile motion problems we're going to be solving, and we're going to be solving each problem consecutively, so if you want, you can stop the video to read each problem individually. By looking at this image, you can see the different formulas you can use to solve projectile motion problems. All projectile motion problems can be solved differently depending on the variables you're giving. So by looking at the next image, you'll see how in Excel we used different symbols to represent the formulas given to solve all the problems with one single calculator.
We used cos multiplied by theta and the initial velocity to find the initial velocity next. Then we did the exact same steps, but instead of using cos, we used sin to find the initial velocity in y. To find time, we used the quadratic formula, and in this case, we had to plug in the formula by using square roots. Initial velocity in y, gravity, and displacement in y. During this video, the first three problems are examples of projectile motion that occurred or happened in ground level. Then from the 4 to the 6 projectile motion problems, we had a different displacement in y, so we used a different formula to find distance. Delta x1 is the distance for the first problems, and we use delta x2 for the 4 to the 5th to the 6th problems. And for this formula, we will multiply the initial velocity in x times y.
In each video, you can see that at the end, I highlight the answers of what you're supposed to get in each problem. In benchmark 1, I shoot an arrow with an initial velocity of 95 meters per second and an angle of 36.5 degrees. How far away from the target do I have to be to hit it? In benchmark 2, I shoot a compound bow with a velocity of 125 meters per second and an angle of 15 degrees. How far away from my target must I stand, and how long will it take it for my arrow to hit the target? In benchmark 3, you see information from the video before, and instead of shooting an arrow on Earth, I'm shooting the arrow on the moon, and the moon has a gravity of 1.620. In benchmark 4, I kick a soccer ball at 25 meters per second off a 2-story building, about 10 meters, at an angle of 67 degrees. How far away from the edge of the building do I need to be to hit a target 30 meters from the building? In benchmark 5, Blaster shoots hydro cannon with an impressive velocity of 500 meters per second. If his opponent is standing on a cliff 15 meters above him, that is 100 meters away, and he's aiming at 58 degrees above horizontal, then how long will it take the shoot to hit the opponent? For the last benchmark, imagine you run and jump off a 12-meter waterfall, and you jump at 15 degrees with a velocity of 7 meters per second. How far from the waterfall will you land, and how long will you be in the air for? This is the end of our projectile motion calculator. I hope you have enjoyed and understand the physics inside our calculator.